For this quiz, we memorized the exponential function, which is f of x equals a times b to the x. And if we remember what each of these stand for, it's going to be very useful over the course of this quiz. So a is our starting value, and b is the common multiple. If we find the pattern between each of these, then we can find our common multiple, and our starting value will also be given by the y-intercept. So that's what we're looking for here, and if you notice, this pattern here is multiplied by 7. We can see we have our value for b, that common multiple. We need our starting value, which is the y-intercept. The y-intercept happens when our x value is 0, and we can see we don't have that x value here. So we need to go back a couple of steps. Step 1, step 0, and if we do that, we'll be able to find our y-intercept. We can use our pattern to do so. We need to divide by 7 in order to get to that next step, and then we're going to divide by 7 again in order to get to the step above it. So if I take 1029 and divide it by 7, I get 147. And then I divide that number by 7 again, and we get 21. And that right there is going to be our y-intercept, because we've gotten back to the starting value. So going back to this equation here, we can take those pieces and put them in their appropriate place. So we have f of x equals, a is our starting value, which is 21. B is our common multiple, which in this case is 7. I put that in parentheses to indicate that it's multiplication, and then our variable x stays there. And we are now finished with that equation. The next one, we're going to use the same strategy. We notice that the values here are decreasing, and they're dividing by 5. Now, our equation f of x equals a times b to the x is based around multiplication. So we are going to rewrite this division as multiplication. Dividing by 5 is the same thing as multiplying by 1/5. So we are going to write it this way. We need to have our y-intercept for our value for a, and we can see that x value of 0 happens right here. It's in the middle of our table this time. So our y-intercept is 10. That gives us an equation then of f of x equals 10. For our y-intercept, our common multiple was 1/5. So 10 times 1/5 to the power of x. X is our variable again, and we are finished with this one. Alright, our next task asks us to draw a graph of the function. So we again can go back to f of x equals a times b to the x. Use our titles that a is our y-intercept and b is our multiple. And we can see right here that our y-intercept happens at -3 and our multiple is 2. So we can use that to start our pattern. We're going to go to -3 here, and then if we go to the next step we multiply by 2, so that would put us at -6. Then it would put us at -12 down there, and we're going to quickly go off the graph here. You can see it's getting steeper and steeper that direction, as our exponential functions do. If we go back the other direction, then we're going to end up dividing by 2 to continue the pattern to the left. So divide by 2 and we end up with 1.5, 1.5, and it'll be negative. And then we divide that in half, we end up with 0.75 or 3/4. That'd be right about there. And we end up with 3/8. Then we keep just dividing those by 2 and we're going to get closer and closer to 0. This graph's going to level out and have our asymptote over here to the left, right along our x-axis. If you weren't sure about all of these points, we could always default to having a table of values where we plug in some x and y values. So we get x and f of x. Pick some x values. Make sure you have some negatives. So -2, -1, 0, 1, 2. That should give you enough points. And then take those x values and plug them into this equation. Then you could use a calculator. If you did that, you would get the values that we got over here when we were using that pattern for multiplication. So I'm not going to redo that, but that is another option that you could use to complete this task. For the domain and range, we're going to take a look at our possible x and y values for this equation. We can plug in any x value, positive, negative, decimal, it all works. So the domain is all real numbers. And for the range, it's our y values. I like to look at the graph for this one. We can see that our asymptote shows us that we are going to approach but never reach the x-axis. That means that our y values get closer and closer to 0. And in this direction we can see that they go all the way down to negative infinity, as low as we want to get. So our range is y values that are less than 0. We get everything less than 0. On our next one, we are supposed to write an equation, and it gives us some information that we have a bacterial culture that starts with 10,000 bacteria and it doubles every day. Doubles is just multiplying by 2. So that pattern right there tells us that it's exponential, and this gives us a starting value. So f of x equals a times b to the x. Our starting value is 10,000, and our multiple is 2, and we have to the power of x. So that's our first part of this task, is to write that equation. We got that, and then it says how many bacteria will be present after 7 days. So we have to make sure that our units match. We have days, and it doubles every day, so we don't have to do any conversion with units. As those match up, we can just take this value of 7 and plug it in. Since we're working with days, that's going to be our value for x. So when we plug that in, we'll get f of 7. f of 7 equals 10,000 times 2 to the 7th power. And you can plug that into a calculator. When we finish that calculation, we get 1,280,000 bacteria after 7 days. This next question and section, we're going to have to solve some exponential functions. And it is super easy to do this if we have a common base right here. So we know that if we have that same base, and in this case the base is both 2, then the exponents also need to be the same in order for them to be equal. So since the exponents need to be the same, all we have to do is figure out what makes 4x the same as x plus 9. We can put an equal symbol there because that means they're the same, and that gives us an equation that we could solve to figure out what x value would we plug in here to get those two parts to be the same. So we're going to solve this by subtracting x from both sides. That gives us 3x, and over on the other side we have 9. Finish by dividing by 3, and we end up with x equals 3. And if we wanted to double check this, we just put it back in the equation. We'd have 2 to the power of 4 times 3, and then 2 to the power of 3 plus 9. Well, that would give us 2 to the power of 12. 4 times 3 is 12. And 2 to the power of 12 on this side. 3 plus 9 is 12. Those are clearly going to be equal to each other as they're all the same numbers. Next, we see that these two bases are not the same. So our goal is to break this down, get the 243 and the 9 to have the same base. And we are going to use rules of exponents after that to try and simplify this. 243 doesn't work nicely with a base of 9, so we can't break it down that way. But we can break both of these down to a base of 3. 243 is 3 to the 5th power, and 9 is 3 to the 2nd power. So those two bases now are going to be the same, and we have to consider the rest of it. So the 243, this 3 to the 5th power, is going to be raised to the power of x still. That comes from there. And this 3 to the 2nd power, that 9, is still being raised to the x minus 2. Keep that equal symbol in there. And now we can simplify using rules of exponents. The power rule tells us that we can multiply those together, and we can multiply those together. So this would give us on the left 3 to the 5x would be our exponent there. And then 2 times x minus 2, we've got to use the distributive property here. And that will give us 2x minus 4. So this will be 3 to the 2x minus 4 power. Now that the base is the same, we can figure out what makes our exponents equal to each other. So that would give us 5x equals 2x minus 4. Solve this by subtracting 2x on both sides. We'll get 3x and a negative 4 over here. divide this by 3, and we end up with x equals negative 4/3. Our next one, we're going to use the same strategy. We want to break this down into the same base, but we have to remember about negative exponents in order to get this one to work nicely. So again, 27 doesn't break down nicely with the base of 9, so we are going to break both of these down to a base of 3. 9 is 3 squared, as we saw on the last one, and we still have the exponent of 2x minus 1 on this side. Over on the left-hand side, we know that 27 is 3 to the third power, but since the 27 was in the denominator, that would be to the negative third power to get that 1 over 27. And we still have the 4 minus x on the exponent there. Now we have the same base here, so we can simplify this and use our same strategy. So using the distributive property here, we're going to distribute that negative 3, and we get 3 to the negative 3 times 4 is negative 12. Negative 3 times negative x is positive 3x. Over here, distributing that, we end up with 3. 2 times 2x is 4x, and 2 times negative 1 is negative 2. Now that we have the same base, we can set these two exponents equal to each other, figure out what makes them the same. So we have negative 12 plus 3x on the left needs to be equal to 4x minus 2 on the right. And let's subtract the 3x this time onto that side, keep it positive. That'll give us negative 12 equals x minus 2. Add the 2 to both sides, and we end up with negative 10 equals x, which is our solution there. So we're done with this one. This equation is not going to work out so nicely because we have stuff that is not going to be able to be the same base over on the left and the right hand side. So we had a lesson on this a little bit ago about separating these two into two separate equations and using a graphing calculator to be able to solve something like this. So our two equations, if we do that, would be f of x equals negative 5 times 7 to the power of 3x plus 2. For our first equation, that's from this left-hand side there. And then the right-hand side, we're going to call this one g of x equals negative 3/4 x plus 8. That would come from this side of the equation. Now I'm going to use GeoGebra as our graphing calculator. You can see that we have both of those plugged into our input bar over here on the left. That first equation, the negative 5 times 7 to the 3x plus 2, is right here. And we can see that looks like this green line. And our second equation, negative 3/4 x plus 8, will be a straight line right there. In this picture, you can see that they don't intersect. This left-hand side is going to get farther away. This right-hand side is going to get farther away. There's no intersection in the middle. And from our knowledge of systems of equations, if there's no intersection, that tells us that there is no solution. So this particular one has no solution. If those two intersected, then we would find the intersection point and we would look at the x value because we're looking for x in this equation, and that would give us our solution. So there will be other situations where you'll have these two and they'll intersect. Say, for example, if we had a different value here like minus 6, you could see we would have a solution there and a second solution there. So make sure you're being careful to find all of your intersection points if you're going to use the graphing calculator to solve these. Alright, next we're going to see a few different situations where we can use exponential functions. So we are going to continue to use f of x equals a times b to the x. We can see that we have deposited $7,500 into our bank account right there, and we earn 2.5% compounded annually. So that $7,500 is going to be our starting value here for a, 7,500. And our 2.5% gives us our multiple if we think about it this way. So 100% would represent our original amount. That 2.5% is how much it's growing. So at the end of the year, we'll end up at 102.5% of what we had before. We can calculate 102.5% of something by putting this in decimal form. That would give us 1.025, and that is going to be our multiple. So that's going to be the value that we choose to use for B. Let me give myself some room here. All right, we get 1.025 now as our multiple, and it's going to be to the power of x. So there's our equation. That's what we're going to put right here. The second part of this question asks for the balance after 10 years. So annually, right here, tells us it's each year. So these units right here for the x are just years. We just have to plug a 10 into there. So if we erase this x, plug a 10 in there, we should do it on the other side where we have f of x, plug a 10 in there, and then we just calculate this. So plugging this equation over here into the calculator, 7,500 times 1.025 to the power of 10 would get us 9600.63, and the decimal continues to go after that. But this is money, so we're going to stop right there and just round it to the value that makes the most sense in the context here. So our $7,500 balance ended up becoming $9,600.63. On our next one, we can see that our growth is again 2% here, and so we can do that what we did before to find our multiple. So 100% was our full amount. We're going to add the 2% to that, and at the end of the year we end up with 102% of what we had before. Turning that into a decimal form, we end up with 1.02. Now we need to read through here, and it says considering July 2016 to be year 0. That's important because we need a starting value, and we've decided that July 2016 is our starting value, at which point it was 3.1 million. So when we have our equation, f of x equals a times b to the x, we now have our starting value, 3.1 million, which we'll write as 3.1, and 1.02 is our multiple, and our power of x stays there. So that would be our equation. That's what we're going to write here. And then we plug in some values to figure out how much it's going to be after 20 years. So this again is annually, and that 20 years is going to end up going there. So we have in our calculator 3.1 times 1.02 to the power of 20. Plugging that in, we get 4.6, and that decimal keeps going, but I'm going to stop there because you were instructed to round to the 1/10 of a million, and that would be the place. So we'd end up with 4.6 million people. And our final question, we can see that we average 4% less each year. So this is going to be our exponential decay. We can still use exponential functions. F of x equals a times b to the x. We have our starting value here at 117,000. So 117,000. The difference on this one is that we need to decay, so we're going to start at our 100%, but instead of adding, we're going to subtract that 4% because we are getting 4% less every single year. That means at the end of the year we're going to be at 96%. Turn that into its decimal form, and we get 0.96. That will be our multiple here, so we're going to put that into the equation. 0.96 to the power of x, and f of x over on the left side. So we now have our equation right there. The end of this question asks us to calculate our earnings at year 5. So we're going to plug in a 5 there. That would get us 117,000 times 0.96 to the power of 5. Plugging that into a calculator, we end up with 95,398. The decimal keeps going, 0.6056. So if you wanted to round it to money, you could keep this much, and it would make sense. I think since we are given just a dollar amount right here, I probably would leave these decimals off and just give a dollar amount. It doesn't matter a ton when you're talking about 95,000 if you have a few cents. So I would be okay with it either way. Thank you for watching and good luck.